Hello, this is Howard Hillstrom, Senior Director of the Leon Root Motion Analysis Laboratory at the Hospital for Special Surgery. Today's presentation is entitled Comparing Surface Topographic Range of Motion in Pediatric Patients with Scheuermann's Kyphosis to Healthy Controls. By way of introduction, Scheuermann's kyphosis is a structural deformity of the thoracic spine, typically recognized by spinal curvature in the sagittal plane. Scheuermann's kyphosis can also include coronal and axial deformity, which can affect a patient's range of motion. This study compares the range of motion of pediatric patients with Scheuermann's kyphosis to healthy controls using surface topographic scanning, which reliably measures spinal range of motion in 3D views without radiation exposure. By way of methods, patients were retrospectively drawn from a prospectively collected surface topography registry for pediatric Scheuermann's kyphosis patients and healthy controls between the ages of 11 and 21 years. Surface topographic scans were drawn from the following range of motion poses: maximum forward bend in the sagittal plane, left and right maximum torso twisting in the axial plane, and left and right maximum torso bending in the coronal plane. Range of motion was calculated in each plane by tracking the PSIS, vertebral prominence, and jugular notch landmarks. Descriptive statistics were performed for demographic data and primary outcomes. Analysis of covariance was used to determine differences in range of motion and asymmetry in Scheuermann's kyphosis patients versus controls. Table 1 illustrates the results for surface topographic values for the sagittal plane range of motion, which was significantly different and larger for controls, smaller for Scheuermann's kyphosis patients, coronal plane range of motion, which was also significantly smaller for Scheuermann's kyphosis patients, and axial plane range of motion, which again was smaller for Scheuermann's kyphosis patients than controls. Coronal angle asymmetry was not significantly different between Scheuermann's kyphosis and controls, and axial angle asymmetry was significantly different, again with Scheuermann's kyphosis patients demonstrating the most prominent asymmetry. Figure 1 illustrates graphically what these movements look like. In A, you can see the side bending right to left. In B, using the torso surface mesh, looking from top to bottom, you can see the axial rotations, internal and external. And finally, in C, you can see in the sagittal plane the side bending commensurate with an Adams forward bend test. To conclude, patients with Scheuermann's kyphosis have limited spine range of motion compared to controls in all three planes. Previous literature has documented and demonstrated a deficit in sagittal plane range of motion, but our results suggest that range of motion assessment should not be limited to this plane alone. Additionally, this study highlights surface topographic scanning as a radiation-free method for reliably assessing spinal range of motion.